I am Dr. Sahaya Sudherson, Associate Professor at Department of Mechanical Engineering, Rohini College of Engineering and Technology. Today, I am going to discuss about bevel gear design, which comes under the subject Design of Transmission System, subject code ME 8651. Dear students, listen to this video. Before we deal inside the subject, we can see about the course outcome. After successful completion of the course, the student should be able to analyze the concept of the design in the flexible drive elements like belt, chain and rope drives. The student should be able to develop the method of various types of gears with parallel axis. The student should be able to develop a method for various types of gear with inclination with angle axis. The student should be able to explain the techniques used in industrial design multi-speed gearbox application. The student should be able to categorize the suitable design for cam, clutches and brakes for automotive application. Introduction of gears. Gears are among the most important power transmission elements. A gear is a rotating machine element having cut teeth which mess with another tooth part, usually having a teeth of similar size and shape. In order to transmit power, two or more gears working together are called transmission and can produce mechanical advantage and thus may be considered a simple machine. Bevel gear. Bevel gears are gears where the axis of the two shaft intersect and the tooth bearing faces of the gears themselves are coincidentally shaped. Bevel gears are most often mounted off shafts that are 90-degree apart but can be designed to work to other angles as well. The pitch surface of bevel gears is a cone. These are the bevel gear types: straight, mitre, spiral, kypoid, spiral. So nomenclature of bevel gear: cone distance, cone center, root cone, face cone, pitch cone, pinion clearance, back cone. Application of bevel gear: food canning equipment, food packing equipment, welding positioning equipment, garden equipment, machine tool including lathe and mills, compression system for the oil and gas markets. Advantage of bevel gears. This gear makes it possible to change the operating angle, possibility to change operation angle, high reliable. It can transmit the exact velocity ratio. Disadvantage of bevel gear. One wheel of such gear is designed to work with the complementary wheel and no other. Must be precisely mounted. Shaft's bearing will be exposed in significant force. It is limited to gear ratio less than 5. High expensive. Any error in the tooth may be lead to high vibration and noise. Bevel gear design. Step 1. Calculation of gear ratio. I equal to NA/NB load equal to ZA by ZA, where NA and B speed of the driver and driven respectively, ZA ZB number of teeth and driver and driven respectively. Then step 2, selection of the material, consulting the page number 8.4 and 8.5, knowing the gear ratio I, choose the suitable material. Step 3, gear life. If the gear life not given, assume as 2000 hours. Step 4, calculation of initial design torque. Utilizing the page number, data book page number 8.15, design torque equal to MT into K into KD. So K load factor, KD dynamic load factor, assume K into KD 1.3. Step 5, calculation of equivalent bending and crushing stress. Utilize the page number 8.16 and 8.18. Using the relation, we will get the bending and crushing stress. Calculation of step 6, calculation of cone distance A, page number 8.13, PhD data book, page number 8.13, having a formula for calculating the center distance. So you utilize the formula and substituting the value, we will get the center distance. Then step 7, select the number of teeth and gear and pinion. So initially Z1 assume 18, Z2 I into Z1. Then step 8, calculation of module. Page number 8.13a. So having a formula, utilize that formula, we will get the module. So module M equal to 2a divided by Z1 plus Z2. Then finally, we want to standardize the module, utilize the page number 8.2. Then step 9, revision of center distance M. Utilizing the formula and 0.5 mt root of Z1 square plus Z2 square. Then calculating step 10, calculating the basic parameters, phase width, pitch dia, pitch line velocity. You utilize the formula using the above mentioned formula, getting the values. Then step 11, selection of quality of gear. Knowing the pitch line velocity and consulting the page number 8.3, select suitable quality of gear. Step 12, revision of design torque. Using the calculated value of psi p and revise the k value by using the formula 8.15. Revised design torque should be calculated. Step 13, check for bending. So PST data book, page number 8.13a, having a checking bending stress, utilize this formula, find out the stress checking. Then check for wear strength. So page number 8.13, having a formula. From the formula, we can able to calculate the induced contact stress. The condition is induced contact stress less than or equal to assumed stress. So design is safe. Then step 15, if the design is not satisfactory, we can change the module and phase width value. Automatically the condition will be will be the safe condition. Check for gear. For checking the gear, we want to check bending and wear checking. The condition is also same. These are the systematic procedure for design the bevel gear. Thank you.